A decision tree is a specific type of probability tree that enables you to make a decision about some kind of process. For example, you might want to choose between manufacturing item A or item B or investing in choice 1, 2 or 3. We usually take some sort of decisions to come to a conclusion, and that's exactly how your decision tree classifier works. Let's try to take some examples. Imagine you are working for a company where you need to call multiple customers to convert them or force them to take your credit card. Imagine you have 1 million records, and obviously from 1 million records, some of your customers might already be having some credit cards and some might not be having credit cards. Let's say the decision tree looks like this: age, people with less than 20, 20 to 50 and 50 plus. Less than 20 are around 10% of your customers. That means out of 1 million, 0.1 million customers fall into this category where their age is less than 20. People with the age of 20 to 50 are around 80% and greater than 50 are around 10%. That means majority of your people are in the range of 20 to 50. From 20 to 50, probably you further go ahead and see how many of them are married and how many of them are not married. Out of these 80% records, which is 0.8 million records, let's say 80% of the records are married and 20% of the records are not married. Again, from married, probably you see the next feature, which is having kids or not having kids. You try to understand that majority of the people who have taken credit cards are having kids. So from this particular decision tree or from this particular tree, who is your target customer? Your target customer is people with 20 to 50 years of age who are married and who are having kids. Now, out of this 1 million database, if you spot somebody having all these features, then you should definitely call them in order to convert your credit card, in order to sell your credit card. We also can take another example related to decision trees. One of the classic examples is when we get a job. Whenever we get a job, let's say you are currently working in a company called as X, and you got some multiple offers from A, B and C companies. Definitely what comes to our head is salary. Let's say my current salary is 10,000 and the salary that you are getting is around 20,000, 30,000 or 40,000. But in our head, whenever we get a new job, we usually think about salary first. Is my salary less than 20,000? If yes, I will directly reject the job. I will not take the job. Is my salary in the range of 20 to 50? Then probably I will definitely take the job. Or it's up to you whether you will take the job or you want to think about some other features. Let's say here you want to think about other features. And if the salary is greater than 50, I will definitely take the job. If your salary is in this range, probably you will think, what is the location? Is it near the metro, near the MTR stations or near the central location, or it is far away, outskirts? If it is in outskirts, again you will think about some other things. What is the rental fees of a flat over there? And then probably you decide whether you take this or not. If it is near to MTR, you probably take the job. Now this is a decision tree that we basically create in our head. Now based on the company's location, based on the company's salary, if the salary is around 30,000 and it is near MTR location, definitely I will take the job. So that is how your decision tree works. Now coming back to the data, whenever we have data, whenever we have a classification data, how our classification algorithm, which is called as decision tree classifier, be able to create such kind of trees. Let's try to take a look at that. Before getting into that, let's try to talk about some terminologies. Normally, a decision tree looks like this. The top node, this particular node, is called as root node. And normally, the most important feature sits on top. In the previous example, salary was my topmost feature. That means salary is the topmost feature based on which I will take my decision whether I will join this company or not. That becomes your root node or the king node. This node is called as decision node, decision node, decision node. And all the nodes where you don't have any further steps are called as leaf nodes, leaf nodes. And that's how your decision tree looks like. Based on the type of data that you have, where you have multiple features, age, salary, location, blah, 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 based on that, your decision tree algorithm helps you to create a tree like this. And based on that tree, you will be able to take decisions. So, decision trees are used when the data is not linearly separable. It is a binary tree that recursively splits a dataset until we are left with pure leaf node. What is the concept of pure leaf node? We'll take another example to understand that. Let's try to take a graph. So we have x0 and we have x1. Why we are considering only two features? Because we are plotting it. We cannot plot anything beyond two features, right? 3 dimensions, 4 dimensions, it's difficult to plot. So that is one of the reasons why I'm only considering x0 and x1. So let me just draw this and then I will explain. -5, -10, -15, -20, and so on here also. -5, -10, -15, -20. Okay. Now I'll try to draw some of the data points. So for class A, probably I'll use a green color. Let's say one of them is here and one of them is here. One of them is here and one of them is here. One of them is here and one of them is probably around here. 6 data points. For class 2, let's say one of them is here. One of them is here. One of them is around here. One of them is here. One of them is probably here. One of them is around here. And one of them is here. Okay. So how many data points do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 data points, out of which 7 belongs to class star and 6 belongs to class 0 or O or circle. So these are two different classes. Now the question is, are the data points linearly separable? The answer is no. We cannot simply draw a line and say that anything above that line belongs to class A, anything below the line belongs to class B. No, it's not the case. So the data points are not linearly separable. Now how to solve this using a decision tree classifier? So we'll try to solve this using a decision tree classifier. So in order to solve a decision tree classifier, we need to draw something like this. We have to draw a tree. So let's say my first condition is x0 is less than equals to -10. x0 is less than equals to -10. Is it true or not? If it is true, that means x0 less than equals to -10, which basically means this. How many data points? 3 data points are falling under class star. So I will predict it as star. How many are there? 3 stars. If this is not true, that means all these data points. How many data points? 1, 2, 3, 4. So 4 stars and 6 circles. Fine. anything that is not true here. That means 4 stars and 6 circles. Now the second condition will be, let's say x0 is less than equals to 10. That means this particular line. Less than equals to 10. Yes or no? If it is no, how many stars? There are 2 stars. If it is yes, how many stars? There are 2 stars here and 6 circles. Fine. Now further here, I will give another condition based on my x1. Let's say x1 is less than equals to 10. Where it is? Here. Less than equals to 10. Greater than equals to 10. That means if it is not true, how many stars? Greater than x1 greater than 10, we have 3 data points. But I'm just talking about this range. In this range, only 1 star, right? So it will be star and only 1 star. And if it is yes, 1, 2, 3, 4, 5, 6 and 1 star. So 1 star and 6 circles. Again, what I will do is I'll plot a line here. x1 greater than 10. If it is true, if it is false. If it is true, greater than minus 10. Greater than minus 10. Greater than minus 10. Yes means star and no means circle. How many star? 1 star and 6 circles. Now this is finally my decision tree. Now if you are talking about a data point like this, let's say we are talking about a data point somewhere here. The data point's coordinate is 15, 5. That means x0 is 15 and x1 is 5. We'll try to go ahead here. Does this satisfy? X0 is less than equals to 10? No. So it goes here. Does this satisfy? Yes. X0 is less than equals to 10? No. Right? X0 is greater than. So this satisfied and we predict it as star. So this point is predicted as star based on this decision tree classifier. And this is my decision tree. Now the question that you would be asking is, this might not be the case for more complex data, right? The data that we have used here is very simple, 2-dimensional graph with some data points which is not linearly separable but visually separable. Within our eyes, I can mathematically solve this problem and also get the output. This is just for the sake of example. There could be more complex data. How can decision trees be useful? We might not have 100% pure leaf. Now what is the meaning of pure leaf? In this particular diagram, this is your root node, this is your leaf node, this is your leaf node, leaf node, leaf node, leaf node. And you can see each and every leaf node is pure. Why? If the data point falls here, it is star class. Data point falls here, star. Falls here, star. Falls here, circle. Falls here, star. That means it's a pure leaf node. What if there will be a case where you are not able to solve a problem, you are building your decision trees and you are still not able to solve? Like in this one, you see 1 star and 1 circle. Just imagine. Now this is not a pure leaf node. Okay. In this case, what we'll do is we will further divide so that we have a pure leaf node. And that's based on a data scientist, how to build it. Now, coming back to the topic of decision trees, we might not have 100% pure leaf nodes. In those cases, we perform majority voting and assign majority class to the data point. Imagine this is not a pure leaf node. We have 2 from class star and 7 from class circle. And if based on particular data point, it falls under this category. So what should you predict? It is not a pure leaf node. The prediction will be circle class because of majority voting. Now, you might also be thinking right now that this looks like a bunch of if-else blocks, bunch of if-else statements. Why do we consider this as machine learning? Well, it is bunch of if-else blocks, agreed, but we need to know the correct condition. Now, this condition is arbitrarily taken by me. In certain scenarios where your data is too complex, you're dealing with hundreds and hundreds of features. In that case, manually nobody will be able to come up with a solution like this. You always need an algorithm to solve it. And the algorithm knows the best possible criteria based on which your tree will be created. So there are many possible splitting conditions, and decision tree algorithm helps to find the best split. So summarizing everything, whenever you have a data set and you want to use that data set to create a decision tree classifier using your decision tree algorithms, the first thing is to identify the best possible root node. That means which particular feature is most important. And based on that, you keep creating your decision tree, and based on that, for a new data point, you will be able to predict whether it is falling in this class or that class. So that is all about decision trees. In the next video, we shall be talking about the practical approach on how to create our first decision tree classifier using a sample data set.